They thought the bridge was protected, the negotiations had bought time, and nothing could go wrong. Then the convoy stopped without a single shot fired. What happened next wasn't an explosion, a strike, or a warning. It was a system collapsing from the inside. This was supposed to be a routine crossing until the footage emerged and revealed one of the most calculated military failures of the modern war. Ukraine's negotiations were widely interpreted as a diplomatic failure, but that interpretation misunderstands their true function. For Ukraine, the talks were never primarily about compromise or resolution. They were a deliberate timing instrument designed to shape Russian expectations and behavior. Diplomacy was used not as a bridge to peace, but as a mechanism to slow, misdirect, and psychologically condition the opposing command structure. By engaging seriously, prolonging discussions, and allowing talks to reach a final tense stage, Ukraine encouraged Moscow to believe that escalation would be politically constrained in the short term. This belief mattered more than any written agreement. When Russia demanded absolute protection guarantees for the bridge, Ukraine's refusal was not defiance for its own sake. It was a calculated move to extract intelligence. That single demand exposed which asset Russian planners considered indispensable, revealing both logistical dependence and emotional investment. In effect, the negotiation table became a reconnaissance platform, mapping priorities without deploying a single sensor. The moment talks collapsed, the psychological dynamics shifted exactly as Ukraine anticipated. Russian leadership did not interpret the breakdown as a warning to slow down, but as a provocation that required immediate assertion of control. Anger and urgency replaced caution. The assumption that diplomacy had bought time flipped into a fear that time was running out, triggering rushed decisions and accelerated logistics movements. This was the opening Ukraine had been waiting for. The collapse of negotiations functioned as a silent signal, not to Ukrainian forces, but to Russian planners, nudging them toward haste and predictability. Ukraine did not need to guess when supplies would move or where pressure would concentrate. Those decisions were made almost automatically by the psychological momentum of failed talks. In this sense, diplomacy became a force multiplier. It shaped tempo, compressed Russian decision cycles, and aligned enemy actions with Ukrainian preparation. What appeared externally as a breakdown in dialogue was internally a synchronization point where political theater and military timing converged. The success of the operation began not with drones or explosives, but with the precise moment when words stopped and assumptions took over. Russian decision-making in the hours following the failed negotiations reveals how emotion can quietly become an operational liability. Anger, when it enters a command system, does not announce itself as recklessness. It often presents as decisiveness. In this case, frustration over perceived defiance, shortened planning cycles, and compressed timelines that normally exist to surface risk. Convoy assembly was accelerated, not because conditions were favorable, but because delay felt intolerable. The result was movement driven by urgency rather than analysis. Risk assessments were narrowed, alternative routes were dismissed, and warning signs that might have prompted caution were reframed as inconveniences. This was not a collapse of competence, but a subtle erosion of judgment caused by emotional momentum. Commanders faced an unspoken pressure to demonstrate control. After diplomacy failed, restraint began to look like weakness. Moving supplies quickly and visibly across a critical bridge became a symbolic act, a way to assert authority and show that negotiations had not constrained military freedom of action. Defensive discipline suffered as a result. Spacing regulations were relaxed, security assumptions went unchallenged, and the emphasis shifted from protecting the system to proving it still worked. The convoy was not just a logistical movement, it was a statement. In hierarchical command structures, such statements often travel downward faster than questions, and subordinates tend to execute intent even when circumstances argue for hesitation. This pattern is not unique to one battlefield. Highly centralized systems are particularly vulnerable to emotional signals from above because initiative is measured by speed rather than skepticism. Analytical caution, which requires time and permission to challenge assumptions, was overtaken by the desire to act. Some observers may view this as an avoidable miscalculation, evidence that emotion has no place in military planning. Others might argue that under political and psychological pressure, rapid action was the only viable choice available to Russian commanders. The tension between those interpretations is worth considering. If anger can accelerate action but distort perception, where should modern command systems draw the line between decisiveness and discipline? I'd be interested to hear how you see it. Feel free to share your perspective in the comments. One of the most consequential errors in this operation was not tactical, but conceptual. The bridge was classified as transit infrastructure, rather than as a system capable of being contested, manipulated, or weaponized. Russian planners treated it as a neutral object, whose role was to carry forces from one side to the other, assuming that threats would originate externally and move toward it. As a result, defensive measures were designed to intercept incoming attacks, drones in the sky, missiles from a distance, artillery from known firing zones. What was never seriously considered was the possibility that the bridge itself could already be part of the battle space. Protection focused on the airspace above and the approaches around it, while the structure, its undersides, joints, and load-bearing components remained largely unexamined. This misclassification created a blind spot that no amount of air defense could compensate for. By assuming the bridge was passive, Russian doctrine implicitly ruled out the idea that it could be pre-weaponized long before any convoy approached. There were no procedures for inspecting embedded threats, no sensors monitoring structural anomalies, and no standing assumption that infrastructure might already contain dormant systems waiting for activation. In traditional warfare, bridges are destroyed by external force bombs, missiles, or demolition teams racing against time. Here, the bridge did not become a target at the moment of attack. It became a weapon through prior positioning. That distinction fundamentally changes how defense should be organized, yet doctrine had not caught up to that reality. More broadly, this reflects a failure to adapt to a battlefield where civilian infrastructure can no longer be treated as neutral or static. Roads, bridges, power lines, and tunnels are increasingly dual-use systems that can be surveilled, shaped, and exploited over time. When planners continue to categorize them as background elements rather than active components of conflict, they leave themselves vulnerable to precisely this kind of operation. The bridge was not lost because defenses were absent. It was lost because the wrong question was being asked. Instead of asking how to protect it from attack, Russian planners should have been asking whether it was already compromised. A critical innovation in this operation lay in how Ukraine exploited deeply rooted engineering assumptions about what constitutes a dangerous weapon. Russian assessments were built around explosive thresholds. How many kilograms of charge are required to visibly damage reinforced concrete? How large a blast must be to collapse a span? How much force qualifies as structurally significant? Small charges fell below those thresholds and were therefore categorized as nuisances rather than threats. This framework made sense in an era when destruction depended on overwhelming force applied from outside a structure. Ukraine deliberately stepped beneath that framework instead of confronting it directly. Rather than seeking blast magnitude, Ukrainian planners focused on stress concentration. Bridges are not held up evenly. They rely on specific load-bearing nodes where forces are transferred, redistributed, and balanced. By placing small charges at those points, the operation targeted the bridge's internal logic rather than its visible mass. The explosives themselves were modest, but their placement exploited mechanical weaknesses that engineers normally account for only under theoretical overload conditions. What mattered was not how loud the detonation would be, but how precisely it disrupted force pathways that the structure depended on to remain stable. This approach inverted traditional calculations. The question was no longer, can this charge destroy concrete, but can this interruption force the material to fail itself? This represents a broader shift in modern warfare, away from firepower-centric thinking and toward material science logic. Instead of overpowering defenses or structures, attackers increasingly aim to manipulate physical systems until collapse becomes inevitable. Energy is applied selectively, guided by simulations, stress models, and probabilistic failure analysis, rather than raw, explosive yield. In such a paradigm, the difference between a harmless object and a decisive weapon is not size, but understanding. Defenders who continue to rely on threshold-based thinking risk, dismissing precisely the kinds of threats most capable of bypassing their assumptions. The bridge did not fail because it was hit with overwhelming force. It failed because its designer's own calculations were turned against it. In that sense, the operation demonstrated that the future battlefield may be won less by who brings the biggest weapons and more by who best understands how materials break. One of the most understated yet decisive elements of the operation was how time itself was transformed into stored energy. Instead of relying on constant movement or visible preparation, the system was designed around waiting. The drones were emplaced and then rendered inert, doing nothing for days at a time. No signals were transmitted, no patterns changed, and no activity suggested imminent action. In conventional thinking, inactivity implies dormancy or irrelevance. Here, inactivity was the weapon. Each passing hour did not weaken the system, but strengthened it, as timing replaced motion as the primary source of leverage. During this waiting period, Russian activity unknowingly became part of the weapon's activation process. Every vehicle that crossed the bridge contributed vibration, oscillation, and load stress that gradually shaped the conditions for failure. Traffic did not trigger alarms because it appeared normal, yet mechanically, it was incrementally charging the system. Stress accumulated, not in the explosives, but in the structure itself. The bridge was being conditioned by routine use, pushed closer to critical thresholds without a single hostile action taking place. By the time the convoy approached, the environment had already been altered in subtle but meaningful ways. This reframes how a battlefield begins. There was no clear line separating preparation from execution, no dramatic transition from peace to attack. The decisive phase occurred long before the first visible engagement in a period that observers would have classified as uneventful. The operation challenges the assumption that combat effectiveness requires constant action. In reality, restraint can generate asymmetry just as effectively as aggression, provided it is guided by precise timing and understanding of system behavior. There is no single correct interpretation here. Some analysts might see this as an example of patience elevated to doctrine, while others could argue it reflects a new form of risk, one that depends heavily on prediction rather than control. Different professionals would likely view this moment in very different ways. What is clear, however, is that by the time the battle seemed to begin, it was already largely decided. What ultimately turned a routine logistics movement into a catastrophe was not enemy fire, but an internal efficiency decision that collapsed under its own logic. In an effort to accelerate the crossing convoy, commanders tightened vehicle spacing, reduced gaps, and prioritized momentum over dispersion. On paper, this made sense. A compressed column moves faster, spends less time exposed, and appears easier to control. In practice, it concentrated mass risk and consequence onto a single structure. The bridge was no longer carrying vehicles in sequence. It was bearing the cumulative weight of an entire system moving as one. Spacing protocols exist precisely to prevent this kind of systemic vulnerability. They are designed to preserve flexibility, allowing vehicles to stop, reverse, or reroute without locking the entire column in place. By ignoring them, mobility was converted into rigidity. Once a single vehicle slowed or failed, there was no buffer to absorb the disruption. The convoy could not stretch, breathe, or adapt. Instead, it compressed further, turning minor friction into total immobilization. What should have been a flowing movement became a static mass, and static mass on a bridge is a structural hazard, regardless of enemy action. At that point, the convoy itself became the destructive force. Thousands of tons of steel, fuel, and ammunition exerted continuous pressure on load-bearing elements that were never designed to sustain prolonged stoppage under peak weight. The bridge did not need to be attacked in the traditional sense. It was being overloaded by the very logistics system it existed to support. This inversion is crucial. Destruction did not arrive from outside, but from within the logic of efficiency itself. Speed, density, and discipline. Normally, strengths combine to produce fragility. The lesson extends beyond this single incident. Modern military logistics often optimize for tempo, throughput, and visibility, assuming that faster movement equals greater safety. This operation exposed the limits of that assumption. When efficiency eliminates redundancy and spacing, it also eliminates resilience. The convoy crossed the bridge, believing it was minimizing risk. In reality, it was assembling all the conditions necessary for failure, transforming its own weight into a weapon long before any external trigger was applied. The most decisive moment of the operation did not originate from a Ukrainian command order or a sudden escalation, but from a mundane mechanical failure inside the Russian convoy. A single drivetrain malfunction under full load forced one vehicle to slow, then stop disrupting the flow of movement at the worst possible location. In traditional narratives of warfare, such incidents are treated as footnotes, unfortunate but inconsequential. Here, that assumption collapses. The failure instantly transformed motion into immobilization, converting a moving column into a static mass balanced on a structure never meant to sustain it for long. What followed was not an enemy-induced crisis, but a self-generated one. This is where the design of Ukraine's operation becomes particularly revealing. The system was not built around a fixed schedule or a precise moment in time. It did not depend on the convoy arriving at exactly 5:18 a.m. or stopping at a specific meter on the bridge. Instead, it was contingency-based, waiting for conditions rather than commanding them. The planners anticipated that complex systems under stress eventually produce friction, mechanical, human, or procedural. The question was not if something would go wrong, but when, and whether the system would be positioned to exploit that moment when it arrived. The drivetrain failure was not the plan, it was the trigger that activated it. This approach reflects a broader shift in modern operations toward probabilistic thinking. Rather than scripting linear sequences, planners increasingly design environments where multiple failure paths converge on the same outcome. Any one of several small disruptions, an engine fault, a braking error, a delayed response, could have generated the same immobilization effect. The operation did not require precision in timing, so much as precision in readiness. Once movement stopped, the probability of decisive structural failure increased dramatically without any change in Ukrainian force posture. In this context, mechanical breakdown becomes strategic. It reveals how modern conflict often turns on ordinary points of failure embedded within complex systems. Victory no longer depends solely on striking first or hardest, but on recognizing that large, tightly coupled systems eventually create their own triggers. The side that prepares to exploit those moments, rather than trying to predict them exactly, gains a decisive advantage. A defining feature of the engagement was that Russian defensive systems did not fail because they were destroyed, but because they reacted too aggressively to uncertainty. Air defenses are designed to impose order on chaos by detecting, tracking, and prioritizing threats. In this case, the effort to regain control of the battle space produced the opposite effect. As soon as irregular signals were detected beneath the bridge, defensive units shifted from passive monitoring to active scanning. That escalation flooded the environment with radar energy, multiplying returns from water, steel, and structural clutter. Instead of clarifying the picture, the sensors began interfering with one another, competing for attention and saturating command channels with ambiguous data. Each additional layer of defense intensified the problem. Expanded scans, overlapped frequencies, degraded resolution, and introduced conflicting tracks. What should have been a layered shield became an electronically crowded space where systems were technically functioning but operationally undermining each other. In an attempt to eliminate uncertainty, commanders increased power output and widened coverage, inadvertently exposing the limits of integration between platforms that were never designed to operate at maximum intensity simultaneously. The battle space became noisier, with every defensive adjustment and meaningful signal was lost inside the noise. This escalation also revealed blind zones rather than closing them. By focusing attention upward and outward, defensive assets neglected the lower structure of the bridge and its immediate surroundings. Sensors were repositioned to track aerial threats, leaving critical areas temporarily unobserved. The irony is that the more energy and capability the system deployed, the narrower its effective awareness became. Defensive dominance created vulnerability by forcing the system to reveal not just what it could see, but what it could not. The collapse, therefore, was not the result of a superior attack overwhelming defenses. It was the product of overreaction within a complex, tightly coupled system. When every component attempted to respond at once, coordination degraded, decision-making slowed, and coverage fractured. This incident illustrates a fundamental risk in modern warfare. Defensive systems can generate instability when they prioritize reaction over restraint. In trying to eliminate uncertainty through escalation, the system created the precise conditions that allowed the decisive action to occur. The strike was constructed to send an economic message as much as a military one. Its logic did not revolve around maximizing destruction, but around forcing a cost imbalance that would compound with every defensive reaction. Low-cost drones were not deployed because they were expendable, but because they were deliberately positioned on the wrong side of the cost curve. Each time Russian air defenses responded, they did so with interceptors and radar activations that were orders of magnitude more expensive than the threats they were addressing. The result was a dynamic where defense itself became a source of loss, regardless of whether it succeeded tactically. Crucially, these defensive responses did not improve outcomes. Missiles launched, radars surged, command systems escalated, but the underlying vulnerability remained unchanged. Every attempt to assert control consumed resources without restoring confidence or stability. This is where the strategic messaging becomes clear. The operation demonstrated that deterrence no longer depends on matching an adversary system for system or platform for platform. Instead, it can be achieved by compelling the opponent to spend disproportionately just to maintain the illusion of control. Over time, that imbalance erodes readiness, confidence, and political patience far more effectively than a single dramatic strike. What makes this approach particularly disruptive is its cumulative nature. One interceptor launch might be dismissed as acceptable. Dozens triggered by low-cost systems create a pattern that planners cannot ignore. The message is not simply that defenses can be bypassed, but that defending is becoming unsustainably expensive. In this framework, escalation favors the side that can absorb loss asymmetrically, turning endurance and economics into decisive factors. This reframes deterrence away from parity and toward exhaustion. The question is no longer who has more missiles or better radar, but who can afford to keep responding under unfavorable terms. The battlefield becomes an accounting problem as much as a tactical one, where every reaction carries an invisible price tag that accumulates over time. If you value objective analysis over speculation and noise, consider following this channel. We focus on how decisions are made and the changes they set in motion. What ultimately collapsed in this operation was not just concrete and steel, but confidence. The physical destruction of the bridge was visible and dramatic, yet its deeper impact unfolded inside Russian planning systems almost immediately. Logistics timelines that had been carefully sequenced across the southern front lost credibility overnight. Routes that were assumed to be dependable suddenly became conditional, and assumptions that underpinned weeks of operational planning could no longer be trusted. When a single corridor can vanish without warning, every downstream calculation becomes unstable. Supply forecasts, unit rotations, and offensive schedules all shift from planning tools into risk estimates. This cognitive shock extended beyond logistics into the political and strategic domain. During negotiations, protection guarantees for key infrastructure were treated as leverage, a way to define red lines and stabilize expectations. Once the bridge was destroyed, those guarantees were exposed as hollow. What had been framed as non-negotiable proved unenforceable, and with that realization came a rapid loss of bargaining power. Escalation could destroy more targets, but it could not restore the assumption that control could be promised or delivered. The credibility gap widened faster than any military response could close it. The operation also highlighted a crucial asymmetry. In modern conflict, certainty is far more fragile than capability. Military forces can be reinforced, new routes can be surveyed, and replacement equipment can be sourced over time. Confidence, once broken, does not regenerate on command. Every future movement now carries the memory of what failed, forcing planners to consider hidden variables they previously dismissed. Even routine decisions become slower and more conservative, not because resources are lacking, but because trust in the system has eroded. In that sense, the bridge's collapse was only the surface event. The more lasting damage occurred in the realm of belief in predictable timelines, in enforceable guarantees, and in the ability to manage escalation through control alone. The operation demonstrated that when certainty is stripped away, escalation loses much of its stabilizing power. Force can punish and deter, but it cannot easily rebuild the confidence required to plan, negotiate, and act with assurance.